in today's webinar, Achieve Your Growth Potential with Next-Gen Content Delivery, sponsored by Varnish Software. Before we begin, I would like to cover a few housekeeping items. On the left-hand side of your screen is the Q&A. If you have any questions during the webcast, please type your question into the Q&A box and submit your questions to our speakers. All questions will be saved, so if we don't get to answer you, we may follow up via email. At the bottom of your audience console are multiple application widgets you can use. If you have any technical difficulties, please click on the yellow help widget. Here you can find answers to common questions. A copy of today's slide deck is available for download in the green resource list widget. Near the end of today's presentation, please take 1 minute to complete the survey that's open in your screen. Your feedback will be extremely helpful. An on-demand version of the webcast will be available about 1 day after the event and can be accessed during the same audience link that was sent to you earlier today. I'd now like to hand the webinar over to Heavy Reading's Principal Analyst, Jennifer Clark.
Thank you so much, James. Welcome, everyone, and happy Valentine's Day. We're delighted to have you this morning or this afternoon if you're on the other side of the Atlantic. And I'm delighted that you're joining us to celebrate the day and hear a little bit about next-gen content delivery. You're going to be hearing from myself and also from Thijs Feryn. And
hi, everyone.
Hey, Thijs. Yeah, good to have you here. And before we jump into his presentation, I just want to share with you some of the research that Omdia has been conducting and with Heavy Reading on the overall CDN market and also on what we're carrying on our CDN networks. Let's face it, video traffic has taken the place of our commute. It's taken the place of air traffic. The pandemic accelerated the widespread adoption of video conferencing platforms, but the genie is not going back in the bottle as restrictions are brought on by the pandemic loosen up. We're still continuing to see video dominate the market, and it will for the foreseeable future, of course, and it will encourage a heavy focus on streaming of content. The graphic here illustrates the growing dominance of ultra-high def worldwide. While this graphic predicts that UHD will surpass HD worldwide between this year and next, it pulled out in front of HD in the US 3 years ago. So UHD and the demands that it places on the network are here to stay and may be becoming worse as we transition ever so slowly from 4K to 8K UHD. For standard definition streaming, you're needing about an average speed of only 3 meg. For HD, it's more like 5 to 8 meg. And for 4K UHD, you really do need 25 meg minimum. But we are recommending, or many folks you will see are recommending a connection of 50 meg to cover all scenarios, live 4K broadcasts requiring more speed, for example, and for those contemplating 8K UHD, prepare for the requirement there for 50 megabits per connectivity per stream, that is. Now, 8K TV is not coming on us anytime soon. It's failing to appeal to consumers, according to some of our latest research, which found that just 2.7 million households worldwide are expected to have 8K by the end of 26. But nevertheless, the traffic that is being imposed on the network by live streaming 4K HD is going to be the norm and is something that we have to contend with, whether we're on the consumer side or on the carrier side. We have seen a growth this growth in video traffic comes an equally positive growth in the CDN market as carriers are working to strike that balance in terms of where they place the content far enough down into the network to conserve network resources and improve the customer experience, but not so far down that they really don't derive a lot of operational benefit because that edge is so granular. So we're looking for a robust CDN solution that can react to the shifting sands of this content, moving with agility as pockets or waves of demand move through the network, similar to the World Cup moving through the network. Content delivery networks have become stronger throughout the past few years. The positive market prospects see the CDNs focusing on regional expansion, also a lot on technological development, and a focus on, what constitutes a CDN or a CDN provider, and what makes most sense for the enterprise that we're dealing with. If you look at the live streaming in general, we've seen it growing significantly. Of course, COVID accelerated the trend, and in the new normal, people are hungrier than ever for entertainment via live events. If you can avoid the hours online to try to get the Taylor Swift tickets, maybe you can eventually see it streamed, if not live, maybe with an additional cost, almost live. So offering a premium service for users and increasing the monetization for content providers has been the industry's aim in 2022, and it continues in 23. Our service providers are looking to increase the monetization by enhancing viewing experiences with new features that result in a higher user engagement. And that's critical because high latency or jitter, unreliable response can ruin even the richest streaming experience. So with that, a brief overview of what we're seeing both in the content side and on the content delivery network side, let me turn it over to Thijs, and he'll tell you a little bit about what they are seeing at Varnish from a potential solution to some of the challenges here. Thijs?
Hi everyone. Welcome to the webinar. Thank you for taking time out of your busy calendars to be here with us. I know you have a lot of stuff going on, so we're grateful that you're here. And to those watching this on demand, also thank you for your interest. And also thank you to you, Jennifer, for your insight and your analysis. And I will drill down on some of the talking points you've positioned here, but more or less from our perspective, my personal perspective and the perspective of Varnish Software. First things first, hi, my name is Thijs. Yes, that's how you pronounce that. I am the technical evangelist at Varnish Software. And for those of you who aren't really familiar with us, Varnish Software is an established player in the web acceleration, content delivery, and application delivery industry. We're the creators of the Varnish Enterprise commercial solution, but a lot of people also know us as one of the main contributors and the company behind the Varnish Cache open source product, which is somewhat of an industry standard when it comes to HTTP acceleration, and that is entrusted by about 10 million websites and 21% of the top 10,000 websites. So that should give you a little bit of an idea of what we do. Now, I'm going to tell you a story that starts like this. We are about to enter a decade of unprecedented digital innovation. Now, while that sounds a lot like storytelling, you will be able to relate to this because you probably see this as well. Like if I look at the attendee list, there's a lot of people here from companies who feel that a lot is bubbling up. In mainstream media, a lot of talk is being done about innovation in the digital sphere, and more professional publications also talk about that. There's this perfect storm, and the stars seem to be aligned at this point. Now, all of this can be traced back to the fact that the price of computing and the availability of connectivity and computing has never been lower in terms of price and never been more available. However, there are some caveats there that are more signs of the time. Those are more like 2022 and 2023 problems. I will address them later on in the presentation. But in general, if we zoom out, we can say, yes, computing is somewhat of a commodity and connectivity as well. But also from the consumer point of view, never have there been more users on the internet. It's been completely democratized. And in terms of how people consume the internet, it happens through a multitude of connected devices. If I look at my household, like I'm wearing a watch, I have a phone, I have a tablet, I have a smart TV. All of this contributes to this revolution that we're seeing. And it's in part also made possible thanks to the technological building blocks that are out there. You don't need to reinvent the wheel. You don't need to build everything from scratch. You can actually build it like you do with Lego bricks. And we consider ourselves one of the building blocks here as Varnish Software. So never has it been easier to build a solution, and the time to market obviously drops. And again, when I look at the at the list of people here, there's probably a lot of experienced veterans out here that will say, yeah, Thijs, that's all fine and dandy, that's all good, but we have seen this before. And yes, I can relate to that. And I use the metaphor of the mobile device quite deliberately, because in the mid-2000s, we've been through the mobile revolution. And while it has changed a lot, I'm here to warn you that what we're about to see will happen at a much bigger scale and with broader domains of application. And I'll stop beating around the bush, I'll name it. The catalyst for all of this is 5G. And I'm not necessarily saying 5G as a technology, not the fact that my phone could have a 5G symbol, or that in the industry, devices will be able to connect over private 5G networks. Not necessarily. What I'm implying is that this 5G will set new expectations and new desires from people consuming it. And I'm talking about 3 key metrics. I'm talking about lower latency. That will be also a thing that we'll be talking about more and more in future presentations and publications. Is the low latency will matter for the future of digital consumption. We talk about video, of course, and that is a very tangible domain of application. But when someone dares to take another step at cloud gaming or remote driving or remote surgery, whoever knows what will happen to this world, low latency will be key. And that is what 5G promises. It also promises a very high throughput, which Jennifer addressed. If at some point there is a player that is going to offer, like one of the hyperscalers or a more specialized company will offer 8K video, and people can buy 8K videos for now, then all bets are off. Also, in terms of concurrency, this is happening at a massive scale. And while this is all great, and while 5G can tackle all of that from a technological point of view, I'd like to remind you that we still rely on the good old internet to deal with that. So yeah, the internet's already very clogged up. It's jammed up. About 80%, if my measurements, if that number is still accurate, is consumed by video. And I could tell you firsthand by talking to some of the CDN, the content delivery networks out there, and I see in the list of attendees that there are quite a number of people who work in that space. You could probably attest to that every time something major happens on the internet. I'll give you a very concrete example. When there is a new release of Modern Warfare, of any of the Call of Duty titles, or another big gaming release, CDN providers are just struggling to find available bandwidth. But I must commend them as well, because you can call them the plumbers of the internet, because they have done a sterling job the last 15 to 20 years to make the internet seem easy from a connectivity point of view. We all know that it's not, and they've made it look so easy. So rather than calling them plumbers, by using the metaphor in this image, we could call them like the giants that carry the world. So thank you, CDNs, for doing that. But here I am to present a more, not necessarily a critical message, but a message that diverges from the typical talking points of CDNs. And the fact that we in our industry as a software company see increasing need for a next generation of content delivery and application delivery solutions. There are some restrictions to the model. First of all, regulatory requirements. Now, also very important that I mention this ahead of time. This is not criticism towards CDNs, right? I'm not trying to take a cheap shot at them. We sometimes partner with CDNs, and I'll repeat that later on. But there are some regulatory requirements that prevent or hinder the use of certain CDNs, because where is your data? Where is your data flowing through? Does the CDN have some of the ISO certifications? Is everything according to plan? And not only from a legal point of view, but also from a compliance point of view. We see that there's an increasing demand for more control and greater transparency. And that's a bit tougher in a product that appeals to, I would say, the mass market from a B2B point of view. We also see this increasing need for customization and integration. People want to tailor the behavior of caching, content delivery, edge technology to their exact needs, and they preferably integrate with existing solutions, which isn't always that easy for certain CDNs. From a technical point of view, so those are a couple of challenges. I'm sure that the industry will meet them. We will meet them from our software perspective. I'm pretty sure that CDN providers will meet them as well in the future. But what we see always is the financial implications of that. It always boils down to money. And I'd like to tell you a story about what would happen in 2020 and 2021. I won't name names, I promise. But I noticed when talking to clients in future or potential clients that they had a record-breaking year, be it video providers, OTT, or gaming studios or people in the gaming industry. 2020 was a record-breaking year. 2021 was pretty good as well for obvious reasons. And while top line revenue was record breaking, if they looked at the bottom line, there were some issues. And that's also a main source of concern for the people that we talk to. Sometimes the more you consume, the prices increase exponentially. And I've known of gaming studios that spend about $25 million a month purely on content delivery. And I've talked to others who see it as a genuine concern. And they're not looking to replace CDNs completely, because that's not feasible, but they're looking at specializing the solutions that they need to get the job done. And in the sites where they already have their own infrastructure and network to double down on maybe other solutions that can drop the cost. Then maybe some of the players are looking to target very specific regions. Maybe they don't need the full coverage of a CDN, or maybe the CDN doesn't offer the coverage in the very specific geographic region where they want to operate. And maybe they have the infrastructure. And maybe you, if you're interested, you have the network. I see that there's a lot of communication companies, telcos, also here in the call. For them, this applies. And in that case, maybe you just need software. And it might be a very cheesy transition into this, but we are a software company that builds these kinds of things. This is a bold statement, but I'll back that up. We're the only software, only fully integrated content delivery solution. It's a big mouthful, right? But what we do is we build software that you can use to either build your own CDN or to attach to your existing CDN solutions. And please do not compare us to CDNs, because we're not pure CDNs. We don't offer a service. We offer software that people use to build it out. And again, I'm not trying to criticize CDNs at all, because we partner with them when it comes to multi-CDN strategies. And a lot of companies that choose us and have other CDNs don't put all their eggs in one basket and usually have a multi-CDN strategy. But the reason why they want to do it more on-prem or have tighter control is they want to own the digital data assets. Every step of the way, every step of the content delivery and application delivery process, they want to control, because they don't want to take risks. And this all fits into a bigger plan. The plan to control the digital experience, because they know how fickle users can be and how competitive this space is. And we believe that as a software vendor, we're in an excellent position because we offer tremendous power. And the reason for that is that our solution is purpose-built, very stable, very efficient. And the fact that 10 million people use the open source product is very telling. We offer sub-millisecond latencies. I think you'll see that in the demo even, that we were going to go sub-millisecond. We can easily handle 100,000 concurrent requests on a single machine. And it's not the latest number, but it's the latest number I can talk about, is that we can process more than 500 gigabits per second on a single machine. And that used to make us the fastest content delivery solution on the planet. But of course, this is a race. And I think someone has caught up. Now, these measurements aren't done by us. This is not us doing these bold statements. It was actually a benchmark by Intel, who was trying to give their latest generation of chips a run for their money. And they benchmarked different kind of content delivery tools. We came out fastest back in the day, but we're ready because we're going to go way beyond that. I can't announce anything yet, but there will be announcements of us going past that. And we're not talking 10 or 20%. I can't say more, but we're definitely in the race. And while this looks like a pretty petty competition, there is a reason to this. And there are some current challenges that make all of this 500 gigs and more very relevant. Because believe it or not, we're still in an energy crisis. While energy prices are gradually dropping, it's still a lot more expensive. So if you could do more with less, if you can get as much work done with less wattage, then that's great. And you can turn that into an ecological and a green point of view as well. Like, you reduce carbon emissions, but you also reduce your cost. Even if you're willing to pay top dollar for energy, there's still some power shortages sometimes. We've heard of major video providers that were planning to build out an extra data center site that couldn't get the power in. So they need to do more with less. And even if you are willing to pay top dollar, even if you have the ability to get the power in, hardware isn't always easy to come by. There's still a chip shortage. So from that perspective, it still matters. Also want to talk about flexibility real quick, and you'll see that in the demo. We offer a thing called DCL, which is short for the Varnish Configuration Language. And it's our own programming language, a domain-specific programming language that allows you to tweak the behavior of the cache to your exact needs. And where, although the syntax is rich, where the syntax ends, VMODs can take over. And VMODs are short for Varnish modules, which are modules that just enrich the language of VCL and can tie themselves into any type of library that is written in C. So that's flexibility from a configuration point of view. From a hosting point of view, you're also extremely flexible, because as long as it runs Linux, we're really happy. So that means you can run it on any type of off-the-shelf hardware. You see that for typical baseline operations, but anything that is very sensitive and very flexible in terms of traffic patterns, a lot of people entrust that to the cloud. And we're also available there, so you can run it in the traditional cloud, if I may call it traditional, and in more cloud native implementations where we use terms like containers, Docker, Kubernetes, and the likes. Now, I could talk about features all day long. Literally, I could spend a day talking about features, but this is not the place, not the time. So if you're interested in hearing about that, maybe check out some of our other presentations, or maybe just get in touch with us. We'll meet with your team, and can show you how to build that and build it along with you. But the lesson here, the lesson to learn, is that we've evolved as a company as well. For more than a decade, if you use the automotive metaphor, we were considered an engine supplier. We built Varnish as the engine of content delivery solutions. If we stay in the automotive theme, we said, here's one of the fastest engines that is out there. Please build your car. And our client said, thanks, we'll do that. And we continue to innovate. But with our experience that we gained, we saw a lot of recurring patterns in how that proverbial sports car was built. To that extent that a couple of years, we started building our own car. And that's the integration. That's what we mean with fully integrated software-only solution. And we do that with two new products that we have to offer. The Varnish controller, which is the control plane that manages it all, and the Varnish traffic router, which is the glue, very opinionated glue that routes traffic to the right nodes. So you can basically build out a multi-pop solution that is either independent or that can hook into existing CDNs. And all of that relies on the edge and allows us to think, or forces us rather, to think in different terms about the edge. Now, for those of you who aren't familiar, the edge is a term we use to refer to the outer tier of our content delivery solution, the outer tier of our web platform, which could be represented by a CDN or by our software. But as time progresses, we see this new trend, and we're dealing with it in our labs as well, is moving away from typical content delivery. While that is still quite relevant, we're seeing to transforming workloads and doing computing on the edge. So we're full on in edge compute territory with VCL already and with future innovations. So that is something that we have to take care of. Now, enough talk. I can explain all that I want, and I could spend days talking about this industry and caching and content delivery. But I think it's time to show what we've got. And before we dive into the demo, I'm going to give you some context about what is going to happen. I'm going to build a multi-pop CDN. It has presence in the US, in the EU, and the Asia Pacific region. It's for flexibility reasons. I've just deployed a demo environment on Amazon, and we'll be using the Varnish edge caches to provide the speed and the resilience to offload traffic from the origin. There's multiple POP nodes in each POP, and all of this comes together through, on the right upper hand corner, you can see the Varnish controller as the control plane. So all of the configuration and the management will be done in there through a graphical user interface to make it a bit more visually appealing to you. And there's also the Varnish traffic router in each of the data centers that exposes itself over two interfaces. The typical DNS interface that regular CDNs use as well, where if you go to a domain name, the DNS system that hooks into the content delivery platform knows which nodes are available, which one is closest and best, and will pick that one. We do that as well. But for video workloads that can't rely on potential DNS caching, we offer an interface, an HTTP interface on the traffic routers that you can tie your video player to, and that will do the redirections every single time you hit one. So you're not prone to any additional latency or any caching that your DNS might do. So with that being said, let's have a look at the demo.
All right, here's the application that we're going to accelerate. In the diagram before I started this demo, you saw the different kinds of points of presence that I'm about to create. I'm going to create content delivery resources in the US, the EU, and the Asia Pacific region. But before I do that, I need to introduce you to that application. This is it. It's a pretty basic website that is focused on video playback. You can see the 3 posters of the video, so that's already the imagery. And then when I click it, you'll see the video itself. Besides that, you have the basic web page, you have the CSS, the JavaScript. So when I click these videos, and mind you, I'm not picking these videos because I like them so much. These videos, both Big Buck Bunny, Sintel, and Tears of Steel, are free, open source, royalty free, and I'm also free at liberty to modify them, and that's exactly what I'm doing. So when I play the Big Buck Bunny, you will see some video being played back with a label on top of it. What you see is the location, so EU in this case, the resolution, already 1080p, and the available bitrate. In the upper right hand corner of the screen, you see the available bandwidth on my system. So this is ABR, adaptive bitrate filtering. What it does is it measures the available bandwidth and then selects the resolution accordingly. That is all happening in the video player. Now, throughout this demo, you'll see that we're going to create content delivery resources in various regions so that EU might end up being US and APAC depending. So everything's very smooth. We're able to stream perfect 1080p through, but then of course you need to anticipate spikes of traffic, popularity, and no origin system is able to cope with that without having a content delivery shield in front of it. So I'm going to illustrate that right now. So I'm going to switch to a terminal where you'll see a load testing system running. It generates synthetic traffic from the 3 regions. So the upper row is Ireland. That's where our EU point of presence is. The middle row is California. That's where our US point of presence is. And the bottom, that's Singapore. That's our Asia Pacific point of presence. And it's already generating artificial traffic to a 4K segment from the Sintel video. It does this with a concurrency of 2. So there's 2 virtual users in each region. So a total of 6, which brings along the stability you'd expect. But then of course we could take or give it a run for its money. So what I'm going to do is I'm going to make it tip over and I'm going to generate, let's say 250 concurrent. So by doing this solely from Ireland, a lot more traffic is going to be generated on the origin. But if I switch back to the video, you won't see a lot happening. It's still full HD 1080p, and that is because a lot of buffering happens. You can see if the playhead still has a lot of gray area to cover, that is buffered content. But the bandwidth's already dropping. And if I take you to the statistics, because I'm fortunate enough to have health probes and measurement probes on these load testing systems, I can see how they respond from a client behavior. That's a privilege, because in real life, you hardly have any idea how this is performing from a client-side perspective. So I switch to the window, and we're seeing that it's going very, very poorly. The time to first byte from Ireland is 3 seconds. The other ones aren't great either, but the total loading times are dramatic. 35 seconds from Ireland. And if I would increase the concurrency in the different regions, it would be even worse. So we're having a real problem that the quality of experience drops because the latency increases. So if I take you back to the video, I'm still seeing full HD. That's not the problem, but as soon as I start moving the playhead, you can see that we've been degraded to the lowest of resolutions, 360p. And if I would move the playhead all the way forward, well, then the buffering logo comes and it's really poor. We still have buffered content, so we move the playhead all the way through, and then I don't think the system will survive. So we need to do something about it. The point has been proving. We have 0 kilobytes available. We need a content delivery system in front of it that could take away all the pressure. And that's what we're going to do right now. And this is where the Varnish controller comes into play. It's the control plane behind the Varnish systems that orchestrates them and facilitates both the deployment of VCL configurations as well as traffic routing. So let's start off by showing the Varnish servers that we have available today. There are 6 of them. They come in couples. Edge 1 and Edge 2 in the Asia Pacific region, Edge 1 and 2 in EU, and Edge 1 and Edge 2 in the US. All of this happens through, of course, the controller control plane, but also a tiny piece of agent software that is hosted on the individual content delivery servers, the Varnish servers. Those communicate with the controller and also register the tags. And the tags are really important because we're not managing the Varnish servers individually. We're not treating them as pets, we're treating them as cattle. So as soon as they register with the controller, the tag already categorizes them. And in the end, we're going to create deployments based on tags rather than individual nodes. This means if we take away servers with that tag or add servers, the scaling happens automatically. If I were to click EU Edge 1, you'll see some details about the server. Of course, there's not a lot happening right now because we don't have deployments at this point. What I can show you is some statistics that illustrate the uptime, CPU usage, memory usage, network. Now the uptime is pretty low because before every demo or after every demo rather, I shut down the machines to conserve a bit of money. So what I'm going to show you now is, on the one hand, we have the servers. On the other hand, you have the VCL configuration. Now VCL is short for Varnish Configuration Language, and it is the programming language that allows us to specify the exact behavior we desire from our content delivery machines. Here's the editor, which is a repository of VCL files, presented in such a way like it was an integrated development environment, an IDE. It has code completion, it has color, syntax highlighting, so all of it is there, and I kept it very simple deliberately. So what we're doing is defining a backend, and that backend is actually the server that we're offloading. That is our origin server that you saw in the example. So we're connecting to that, and all these includes represent rules and configuration that I'm not going to expose it to you that much, but you can see its capabilities. We can choose the time to live of individual objects. We can set invalidation logic. We can optimize the images for web by converting JPEGs and PNGs into WebP. We can do synthetic syntax checking. We can expose statistics in the Prometheus format. And finally, we can have a video routing logic available. I'll show one piece of content. Let me take you to the TTL in this tab. What this does is it embeds a module, the URL plus module, and prior to storing objects in the cache, which happens when hooking into this VCL backend response subroutine, the URL will check the extension of whatever's coming in. And if it's TS, JPEG, PNG, CSS, JavaScript, or SVG, we're dealing with static content, so it will cache it for a day. If that doesn't match, so if the if doesn't result in an expression that returns true, well, then this default time to live of an hour gets used. So it's either an hour or a day. And all the VCL code plays along really nice and tunes the behavior of the cache to our exact needs. Now we need to push this edge VCL with all of its includes to the servers. So what we're going to do is we're going to go to VCL groups, which is our configuration. It really ties servers and configs together. We create a VCL group, and I'm just going to call it edge. And this is a multi-tenant system, meaning that you can deploy multiple configurations on here, which results in multiple websites being on the same machine potentially. So that means you can choose it as a shared service. Multi-tenancy goes further, but that's beyond the scope of this webinar, where you can create organizations and accounts, each with their own logins, and you can start deploying different parts of your customer base to that infrastructure. But I know that the hardware is dedicated to my use case. So I'm going to go with root. It's going to be the root VCL. That doesn't mean you can't still do multi-tenancy. It is only, the hardware is only allocated to me, but I can select domains on which we're going to listen. Now for now, the www private CDN varnish.cloud is the endpoint, whereas the demo was solely focused on origin. This is the actual one. And I'm going to explain later why the routers are going to be added as well. You'll see that it will make sense. Here's our deployment, and for now, I'm only going to deploy to the EU. I'm doing acceleration and origin shielding. I'm not thinking too much about content delivery yet. I'm not going to select individual nodes as mentioned. Nodes aren't pets, they're cattle. So I'm going to select them based on their location and their role. I care about EU edge nodes. And those happen to match two machines. If I click them, you see EU edge 2, EU edge 1. Now, to cater for future scalability, I'm going to set the minimum to 1 and the maximum to 10. So that means we can have up to 10 nodes that will be scaled through. And I don't need to manage it. As soon as a new node pops up that has these tags, they'll be added to this deployment. What are we deploying? Well, VCL files. You can choose to create a new VCL file and start typing here. Like this has syntax completion, as you can see. So I can define a backend. But I'm not going to do that, of course, because we already have the VCL in play. So I can select the VCL file from our repo, select Edge, click it, and then all the includes are here as well. And I can show that to you. The TTL, remember that one? It's all here. I can change it and save it in the meanwhile. These edge nodes are being exposed to the end user, so we need to provide logic to determine which requests end up on what node. So I am going to create or add at least a routing rule, but it will result in creating a routing rule because we have none available at this point. So I'm creating a new routing rule, which I also call edge, and you can choose different strategies. Now it's least utilized. We're going to do that based on bandwidth consumption, and the agent software is responsible for that. The agent has a configuration and lists all the network interfaces that need to be managed. It monitors its current bandwidth consumption, but also the maximum bandwidth consumption that the network interface can handle. And if you compare both, you can make a percentage value of consumption, and the one that is least busy will get the traffic. However, there's different strategies, and we can stack them if we want to. Like, you could take random here, and if random would fail, it will take least utilized, but random typically won't fail. It will just generate a random number. So for now, we're going to pick that. Which nodes are going to be randomized? Well, all the ones that match the tags of the deployment, but also the healthy ones. It could be that there's one up for selection that is not healthy, or we won't be selecting that. And the selection happens based on a health check. We're doing an HTTP GET request to this Varnish status endpoint. If it returns 200 OK, then it's healthy. How do we determine this? Well, we can set to 200 here. But for the sake of this demo, we'll tune some settings. We're not going to verify TLS. We're going to assume that the servers are healthy on startup. And typically, a server is considered healthy if 3 out of 8 checks are healthy. I'm going to reduce this. I want to say 2 out of 3 need to be healthy, and we won't be checking them every 5 seconds. We'll be checking them every single second, and the timeout is 2. As mentioned before, the traffic router exposes itself both over HTTP and DNS. HTTP works based on redirections, which I'll show you later. All these settings are good, but I am going to enable the debug headers for your convenience. You'll see why that matters. And from a DNS perspective, I'm going to lower the DNS TTL to 2 seconds, because otherwise this demo could take a lot longer. So what I'm doing is the DNS record that would resolve to an IP address, that decision we're only going to cache for 2 seconds. So as we're doing this, we can create and deploy, and you'll see that this is happening in real time. We're creating the edge nodes, currently inactive, being deployed, and now they're active. So we have a content delivery setup right now, which we can test straight away. If we go to www.privatecdnvarnish.cloud, you see the same content that originates from the same origin web server. It is cached, however, on the edge and is a lot more powerful and less sensitive to high traffic. So if I play the Big Buck Bunny video, you'll see the same thing, EU content 720p. Hopefully it will bump up to 1080 as it figures out that it has more bandwidth available. There you go, we're at 1080p. And I'm going to go back to my load testing tool, which I've already set up, ready to roll with a concurrency of 100 in each data center. So if I resume, we should have 300 concurrent requests originating from 3 different regions. Let's play the video and see if we're still in good shape. Yes, we are in perfect shape. It's 1080p. Now, mind you, based on the previous test, we know that a lot is pre-buffered. So if we move the playhead all the way to the end, it should be able to produce the same content. See, it is not sensitive to that traffic. It can handle a lot more. And if we go to the K6 statistics, you can see that we're in reasonably good shape, not perfect. Let's look at it from an EU point of view. Currently, the time to first byte from Ireland, IR, as you can see, is 2 milliseconds. We often talk about sub-millisecond delivery. I'm pretty sure we can achieve that. It's just a matter of waiting a bit. It is fluctuating, but what we can see that from Ireland, the total request duration is 45 milliseconds, which is well below what you need to make this video flow through in a very fluent way. So we'll let the traffic do what it does and assume that the time to first byte will drop below a millisecond. What is also apparent is that, here we go, we're already below a millisecond in Ireland, but the other stats in the other regions aren't keeping up and aren't maintaining that level of performance. Singapore and the US are quite poor, both from a request duration point of view as well as a time to first byte point of view. And that of course makes total sense because we've only created content delivery resources in the EU. This brings us back to the Varnish controller and back to our VCL group. We can go to this one, the edge one, and edit it. And while I could add extra deployments for US and for APAC, I'm going to play it a bit more lazy. I'm going to edit it, and I don't really care about EU or US. I want it globally. So I'm going to remove the EU tag, and all of a sudden we're matching 6 nodes, all 6 of them. The 2 US ones, the 2 APAC ones, and the EU ones. So we're in good shape here. So as soon as I save and deploy, we're going to have content being served from a variety of regions, which should seal the deal, right? Well, I'm not sure about that. So if we keep playing it and move the playhead forward, let's see what's going on. We're still being served EU content in full HD, and now for some really odd reason, US gets thrown in the mix. So now I'm getting really low quality video from the US, where I'm clearly in Belgium, which is in the EU. So what is going on? If I take you back to the K6 load statistics, K6 is the name of my load generation tool, we see that the numbers are all over the place. Even time to first byte is rapidly increasing in Ireland, whereas we didn't change anything in Ireland, we just added Singapore and United States. The request duration numbers are horrendous as well. And this is not an accident, I did this on purpose. I didn't forget this, but what I didn't do is I didn't change the routing rules. So if I go back to the routers and change my routing rules, you'll see that randomness is the main decision. We're randomizing across all nodes we have available with no regard to the location where our users are. So let's stop doing that and let's do GeoIP. We're going to stack that one on top of it. And we can even select least utilized as the secondary. So if we can't match a node based on the client IP to the closest POP that we have, then we pick the least utilized server. So let's do that. We're going to click save, and things are going to go massively better. As you can see, the numbers aren't there yet, but we're on a downward trend. We're already at 2 milliseconds. US already went below a millisecond. Singapore is struggling a bit, but that's pretty much the thing we have to take into account. This is hosted in the cloud, and for whatever reason, Singapore is not keeping up. The traffic, the network traffic, and the network performance is what it is. But in general, we're doing a really good job from Ireland and from the US. And the video itself, while we're still in the US, if we move the playhead forward, there was even a bit of APAC in there, but it should stabilize now. So it's refreshing. We're at 360p in the EU, but that should climb up quite quickly. And we're already at 720p. So now we're in really good shape. We've created a content delivery network that gives us 1080p, and everything is smooth. But of course, let's bring the video back to the start, because we have some more stuff to show. There's more to the story. Now we're assuming that closest is better, but maybe you have some preconceived assumptions about where you want to have data flow through. And we can influence those decisions. We can actually go to routing decisions and create extensions. You can create external routes that point to maybe external CDNs that you want to balance certain data to. CIDR-based rules, where you can create CIDR rules with subnets that point to specific tags. You could do the same thing for ASN. So while CIDR represent individual subnets that contain multiple IP addresses for specific clientele you have, the ASN is the overarching network. So maybe a network provider has multiple subnets. They will all be associated with the same ASN, which is the unique identifier of the network provider. So you could say everything coming from AT&T, you want to route there. We can also do it based on geolocation, and that's what I'm going to do for now. So I'm going to call this Belgium because I am Belgium. I am located in Belgium. I'm doing this webinar from Belgium. I'm going to pick the least utilized server, and I'm going to match this to Belgium. Need to type it right. Belgium. There's multiple Belgiums, but I'm going to go for Belgium, the country. All traffic from Belgium, I am going to route to the United States. And I'm going to create that routing decision, which is an extension, of course, of whatever we have. And now we need to register it with the routing rule. So I go back to the routing rules, go back to Edge, and I'm going to stack geolocation on top of it, right here. So first rule to be evaluated is geolocation. Which routing decision? Well, the Belgian one. meaning that if we match my client IP to a Belgium IP, this routing rule is gonna be used. This decision is gonna be used. If not, we use GeoIP to find the closest one. If we don't find a match, we'll pick the least utilized one, which could be pretty far out. So we're saving, and the video is still playing in full HD in the EU. I'm gonna move the playhead to influence the decision. And as you can see, we're in the United States. Traffic for Belgium has been routed to the United States, as expected. So you can really have a level of granularity on the decision making. So I'm going to go back and, yeah, the latency is not great because I'm thousands of miles away from that California data center. Remove that again, and then it'll be clever enough to route me back to Ireland, back to the EU POP. Let's move the playhead until the point where it switches. There we go. Let's show you how seamless this is. This is still US, this is EU. Did you see a single glitch in the video footage? You didn't. And that's the last part we're going to cover. That is what the traffic router is really good at. And that's where we're going to have to show you the difference between the DNS and the HTTP endpoint. Let's do that now. How does a user end up on a node? Well, we do this through DNS. So I'm going to run this command, www, we'll do a dig on that, private CDN varnish.cloud, and it will do a DNS resolution, pretty much converting this domain name into the right IP. We'll end up with a proper IP, which is 54.217.18.226, which is probably EU H1 or EU H2. The challenge with that is that these values can get cached by my computer, cached by the DNS server of my internet provider, cached by other DNS servers in the chain. This happens to alleviate pressure on the core DNS servers of the internet, which means there's always a bit of delay in here. And while you can force DNS refresh caching of your computer by doing a hard refresh on your browser, this is not acceptable for video playback. So if something happens to the server, one happens to be more overloaded at a given point in time, you need to be able to do a seamless switch from one to the other, which you've already seen in the demos I've shown you. And that is due to the HTTP interface. So while I've shown you DNS, I'm going to do a HTTP call now. So curl is a command line based HTTP browser. So I'm going to go not to www, but to router EU private CDN varnish.cloud. And I'm going to request the home page here. What is going to happen is that this is the HTTP output that you see. It's going to say, whatever you're looking for, I found it, says the router itself. So we're addressing the router directly. This 302 means that we're going to redirect you to the location where we believe you should be. And that is done through the location header. And it says you need to be at EU Edge 1. That is where the traffic is going through. How was that decision made? Well, it was made based on a GeoIP routing rule. This is my client IP, and all these X headers are debug headers, which of course are going to disappear if I disable that in the controller. And that decision was made in 32 microseconds by router EU. And it associates my location with the city of Torhout, which is in Belgium. It's not my city, but it's pretty close. So it says, you know what, on that proximity, we'll route you all the way there. That endpoint, that router EU endpoint, can be used in the video player to make a decision on every request rather than relying on DNS caching. And I'm going to show you how we did that. Let's go back to the source. This is the JavaScript code that lists the different videos that are going to be available. And you can see that we're pointing to the router EU endpoint. So by using the router explicitly, you'll be able to have that decision making happen on the fly and do a redirection every time. I'm going to show you how we did it on the origin. Let's see if I can just type origin here and get the same result. What you're seeing here is that we're serving it locally, which makes it subject to whatever DNS decision is happening. And that's why we had to turn that into the router. Now, this doesn't happen automatically. I've written VCL code for it. So in fact, I'm not touching the origin application. Within the video router VCL that is embedded, I'm actually matching content that is being returned by the origin and doing find and replaces on it using regular expressions to inject the closest router. So if we're noticing that you're in the EU, we embed the EU router. If you're closer to the US, the US router will make that decision.
Thank you, Thijs. Very, very interesting demo. Very, very enjoyable. And with that, we are going to open it up for questions. And if you have not yet put in your question, please do so via the console, and we have a couple already. So let's dive right into it. Our first question is, do CDN operators struggle to find bandwidth on demand, such as when significant game releases are expected? And what does that struggle mean in practical terms?
Yes, they do struggle. I'm not sure if all of them struggle, but the ones I talk to struggle a bit. That doesn't mean they're absolutely clueless, because they're experts in their domain. What they do, if they're big enough, they usually get the heads up from the big gaming studios that something new is coming up, so they can prime their caches already to avoid having poor latency going to the backend. So they cater to that, but their preferred routes aren't always available with the same level of throughput. So it's always balancing. On the one hand, you have the bandwidth, and on the other hand, you have the latency, and it's just a matter of finding the optimal routes. So from a delivery point of view, I think they do a decent job, but it's all about balancing that out, and it does provide challenges. Let's put it that way.
Sure,
and
consistency
I
across.
That firsthand. I remember when I downloaded the new Call of Duty, it took me 12 hours to download. So, yeah.
Yeah, very
and I have
interesting.
100 megabits at home, but you can't realistically expect that the internet is this magic solution that works all the time. Like, CDNs were given a run for their money.
And it's only going to become more challenging, especially as the gaming industry tries to remove the gaming console from the user site and put it into the network, and then that creates all sorts of additional challenges for
as a matter of fact, there's
content.
no infinite amount of fiber under the ocean, underground. We're even involved in a project with the European Space Agency, where we're actually looking at using satellites for that, or a consortium of companies is looking at satellite communication to tackle some of those limitations of terrestrial internet, specifically in regions that are poorly covered. So
very
people are looking for solutions.
Yeah. They are, and the challenges are only going to become more dramatic. What arguments would you suggest regarding switching from a content delivery solution offered as a service to a privately owned content delivery solution?
Well, of course, from a commercial point of view, I would say do it, but that is not maybe the most honest approach. I would say, if I were to remove my Varnish Software hat and be as neutral as possible, I would say choose whatever makes sense for you in terms of operational complexity, pricing, and do whatever is easiest for you in the beginning. If you feel pain in the early stages, try looking for alternatives. We typically see, we address both web acceleration issues and content delivery issues. From a web acceleration issue, it's easy. If your origin struggles to keep up, you just put a cache in front of it, and that will mostly sort it out. But if you're operating on a global scale where you have people all over the world, and it turns out that CDNs are too expensive, and you have some infrastructure, why not use the software? That's my approach, and that's one of the points I drilled home. But I don't want to make it seem that obvious and easy. Every situation is different, and using traditional CDNs and using like more private CDN will have to go hand in hand. It's not one or the other usually, unless you're targeting very specific regions. We talked to a broadcaster that was in a specific European country where their level of granularity were big cities. So they were looking at like, we want something in the north of the country, something in the south. And like, although CDNs, I've commended them for their work, they might not have that option.
Yeah, absolutely. Absolutely. So here's our next question. Which workloads are likely to run on the edge where the CDNs are versus going all the way up to the cloud?
That is, I'll tell you the answer for what I know now, but that will evolve continuously, right? Depending on the types of the way this is programmed. Again, it's where you feel the pain, and it depends on the verticals. Like workloads that will be computed when we look at it maybe from let's say a retail point of view, shopping cart calculation, user sessions, interacting with cookies, that typical very basic stuff is something you can definitely move to the edge. I'm not pretending that every single part of your application at this point will be moved to the edge. It's not really realistic, because for now, from our perspective, you do this using VCL. We're also looking at other things that are becoming more mainstream, like WebAssembly on the edge. We're definitely looking into that. but that is not a perfect representation of your application. So it's more of and I think software architectures are moving in that direction as well, going from a big monolith application into microservices, and then looking what kind of, or even nano services, looking at what type of workload could be moved to the edge. From a maintenance point of view, does it make sense to put it in a language that is suitable for the edge and then do that? But it's not like this big revolution that all your code is going to be moved to the edge. I don't see that happening relatively soon. It's about the things that cause you the most pain and that need offloading. That's where it's at.
Yeah, absolutely. I hear you. Okay, next question. Would it make sense for cloud workloads of today to go down towards the end? I assume that answer is going to be very similar to the last one, but why don't you tackle that?
It's going to be
one?
exactly the same. It's going to be exactly the same, right? It all depends on where you want to put your money in, like making sure that your development moves towards edge-based programming languages or spending more on cloud infrastructure. I always say throwing money at the problem by scaling your infrastructure on a short-term basis when your house is proverbially on fire. You need to do firefighting. So then you would scale out your clouds horizontally, vertically. But after a while, you look for root causes, try to optimize, and maybe move a little bit more to the edge. Also, maybe in plain basic terms, like just doing more caching. It doesn't always have to be edge compute, right? Sometimes caching does the job. For more personalization, you will move more into interacting with key value stores and databases that are made for such scale.
Yeah, absolutely. All right. That is all our questions for right now. So I am going to wrap up our webinar.
I see one more that we need to address.
Did I miss one?
Someone asked any capabilities to implement HTTPS, and I do want to mention
just came in.
that,
sure.
Yes,
go ahead. Yeah.
Everything you've seen supports HTTPS. It's just lazy me who didn't want to manage all the certificates in this demo setup. So yes, everything can be end-to-end HTTPS. There is no issue there. Thank you for asking, though. So it more exemplifies my laziness in the demo than anything else.
All right, Thijs, thanks a lot. With that,
you.
I'm going to wrap up today's webinar. Thijs, thank you so much for your insights and, a really compelling demo. Is fascinating to see how rapidly you could impact the delivery characteristics, globally, depending upon what you were doing there and etc. So nice job there, and thank you everyone online for listening in. And with that, I'm going to wish everybody a lovely rest of your day, and thank you, Thijs, and this concludes our webinar.